This time we are going to convert octal numbers to decimals. Anytime you want to convert octal to decimal, you're supposed to use the same concept which we used with hexadecimal and binary numbers. What I mean by that? You're supposed to simply write the weights over the digits of the octal number. What I mean weight? You're supposed to just take the base and just write the exponent next to it. So, what is this? 820 times 7. 820 is equal 1 times 7 is equal 7. So, 7 base 8 is equivalent to 7 base 10. This is the solution to my problem. Let's take a look at this example. We have 27 base 8. We have 2 digits this time. Again, what we're supposed to do, we're supposed to write base over every single digit. Next, we're supposed to write exponent 0, 1. This is exactly the same procedure like we had with hexadecimal numbers, and when we are converting them to decimals. We were always supposed to write the base over every single digit and just write exponent 0, 1. If you had more digits, you had the exponent 0, 1, 2, 3, 4, and so on, so on. Remember, always start with exponent 0. Next, we're supposed to just find the sum of the products of these numbers. So I have 8 to the first times 2, 8 to the first times 2, plus 8 to 0 times 7, where 8 to the first is just 8. 8 times 2 is equal 16, plus 8 to 0 is equal 1. 1 times 7 is 7. 16 plus 7 is equal 23. This is the solution to my problem. It means that 27 base 8 is equivalent to 23 base 10. Next example. Again, we're supposed to write the base over every single digit and write exponent 0, 1. So next we're supposed to perform the multiplication and addition. So I have 8 to the first times 3 plus 8 to 0 times 2, which is equal 8 times 3 is equal 24 plus 8 to 0 is equal 1 times 2 is equal 2, and I have 24 plus 2 is equal 26 base 10. So we can say that 32 base 8 is equivalent to 26 base 10, and this is the solution to my problem.